Single replacement reactions are those that involve a compound reacting with an element. There are 4 types of single replacement reactions: the metal-metal replacement, the halide-halide replacement, active metal and water, active metal and acid. All the information you need for every single replacement reaction is contained on this activity series. Let's examine it. On the activity series, the most reactive metals are on top. So lithium is the most reactive metal. The least reactive is on bottom, gold. More reactive metals can replace less reactive metals in compound. So if potassium is by itself and sodium is in compound, potassium will replace sodium. Also on this chart, you can find who will replace hydrogen from water, and specifically, is it cold water or steam? All of these will replace hydrogen from cold water. In addition to the originals, you can add another group. They will replace hydrogen from steam. All of them, down through lead, will replace hydrogen from acid. And all of them, down through copper, will form oxides. These elements down here, these metals, do not react with water, acid, and they also do not form oxides. Start with a metal-metal replacement. As you can see, we've got a metal and a non-metal reacting with another metal. The blue metal is set aside in favor of the green metal, and the non-metal remains in compound. The big question is, or the thing you have to watch for, is that this metal is more reactive. If it is not more reactive than the one in compound, the reaction does not occur. So let's look at the first example, iron and aluminum. The question is, will iron replace aluminum in compound? So let's look. Aluminum is here, and iron is here. Can iron replace aluminum? Is iron stronger than aluminum? The answer is no, so no reaction. You don't even have to come up with the charges and everything like that, just no reaction. Let's look at aluminum and copper. Can aluminum replace copper in compound? So aluminum is still up here. Copper's down here. So aluminum is stronger than copper, so aluminum can replace copper in compound. This think box is for you to do the charges. We will be grading the think boxes. Aluminum is a 3+ when it's in compound. Cl is a 1-. So what do we get when we put those together? AlCl3, and then copper is all by itself with no charge. We need to balance now. I've got a 2 on the left for copper and a 3 on the right for copper. So I need to look at 6 being the least common multiple. So I'll put a 2 here and a 3 here. And then I need a 3 in front of my copper and a 2 in front of my aluminum. Next, lithium, zinc. Will lithium replace zinc? Lithium will replace anyone. So let's go over here. Lithium is a +1. Chloride is a -1. So my formula is LiCl plus Zn. Now I need to balance. And I'm done. It is very important that you use the think box to come up with the correct formulas. The second type of single replacement reaction we'll look at is the halide-halide replacement. You have a halogen in compound with a metal, and then you've got a halogen that is elemental. Remember, the halogens are diatomics. So the question is, will the halogen in compound be replaced? Same deal as with the metals. You've got a ranking of least to greatest. Fluorine is the greatest reactivity, and iodine is the least reactivity. So when you're looking, bromine, iodine, will bromine replace iodine? And the answer is yes, bromine is more reactive. Will chlorine replace the Br? Yes, it's more reactive. Will the Br replace the Cl? The answer is no. No reaction. Let's look at B. There seems to be a typo on B. That should be a 3. Aluminum's a +3. Bromine's a -1. So let's do that one. We know that the chlorine will replace the bromide. So let's write the new formula. Al is a 3+. Chloride is a 1-. AlCl3. And then bromine by itself. Remember, it's a diatomic. We need to balance. So I'll put a 3 here, a 2 here, and a 2 here, and a 3 here. And it's all balanced. The third type of single replacement reaction is the metal replacing hydrogen in water. So notice the metal comes in and replaces this hydrogen, and you're left with a metal hydroxide and H2. Obviously, it's not balanced here. We'll balance it in our equations. So the question becomes, will the metal replace one of the hydrogens? So iron, let's look. Iron will replace hydrogen from steam. So the answer is yes, that will work. Sodium will replace hydrogen from steam and from cold water. So that will work as well. Silver, however, will not react with water. So let's go ahead and write that as a no reaction. And let's go up here and do one of these. Let's do iron. Iron is a transition metal, so you don't know its charge unless I tell you. If I neglect to tell you, it will be a +2. Transition metals can all form the 2+ ion, so go ahead and use that. Iron, 2+, and it's going to be a hydroxide, so OH-. So let's see, we have iron, hydroxide, and then H2. It's not balanced, but let's go ahead and put a 2 here. The hydrogens are fixed and the oxygens are fixed. The next one, sodium is a plus, hydroxide is a minus, so NaOH plus H2. We need to balance it. So let's put a 2 here, a 2 here, a 2 there, and it's all balanced. The final type of single replacement reaction is the replacement of hydrogen in an acid. So the metal comes in, replaces this hydrogen. You get a metal and a nonmetal, which we call a salt. NaCl is table salt, but any ionic compound is salt. And then you also get hydrogen gas. So let's look over here at the activity series to make sure we know where those will come from. So all of these will replace hydrogen from acids. So sodium definitely will. Zinc definitely will. Silver will not. So no reaction here. So let's look at this. Sodium replaces hydrogen. Na is a plus, Cl is a minus, so NaCl plus H2. It follows the pattern, it's got to have the H2. Then we have to balance it. So 2, then 2, then 2, and we're done. The next one, zinc replaces the hydrogen from sulfuric acid. So zinc, remember I just told you, use a 2 plus for metals that the charges aren't shown. And sulfate is SO4 2 minus. So zinc sulfate and hydrogen gas. And that turns out to be balanced. So there are 4 types of single replacement reactions: metal-metal replacement, halide-halide replacement, replacement of hydrogen from water, and replacement of hydrogen from an acid.